Good afternoon, and you're here with us again on Likeable Science here on Think Tech Hawaii on another lovely Friday afternoon. Likeable Science is all about how science is a fun, vital, and interesting part of all of our lives, how it should be embraced by everyone, man, woman, and child. And today we have actually we're going to do something a little bit different. We actually have Dr. Maria Stewart here from the Department of Human Nutrition, Food and Animal Science Department, UH Manoa, and she's actually going to do some demonstrations for us here, because we're going to be talking about something that's really, everyone knows about it, but nobody really, a lot of people I don't think understand it, dietary fiber, sort of what is this stuff, So, but before we do, a little, my little usual sideline of science campfire stories. And so I used to work in a strange lab, a reptile reproduction lab, and we had these lizards that we worked with called Nematophorus, whiptail lizards. And the unusual thing about these lizards is that the whole species is all female. The whole species is actually all clonal females. They're essentially all the same animal, basically. And while it's a good system in some sense, because if you're all female and able to dump out eggs that are the same as you don't need to spend any time looking for a mate, right? So it saves time and energy. And since these lizards take over disturbed habitat, that's sort of a good thing. Sparse populations and all, not to have to do that. But actually the cute part about them is that we have still their ancestral species are still around, who are sexual species. And these lizards, depending upon their hormonal status, will behave sexually towards one another. They will actually, some of them will play male basically on the female and will mount her and wrap around her in a very, very typical lizard copulatory posture. And if you keep them in a container together, after about 2 weeks, they'll switch roles, and the other one will now be playing male to who was playing female before. And this does apparently stimulate them to lay more eggs, and so they actually reproduce better if they can do that. But anyhow, just one of those weird little science facts. Strange little story. But we're not here to talk about lizard sex, we're here to talk about dietary fiber. So why don't you start, you want to do a setup here, I gather.
Yeah. So Ethan, as I told you, not all fiber is created equal.
Right.
And a lot of folks think that fiber is just one compound or one nutrient. Right. So we're going to set up a little demonstration here so we can see how different types of fiber have different properties and how these properties can relate to different effects in the body.
Excellent.
So I have 3 beakers that are set up on the table. I'm going to add some water to each of these. This is just tap water. And so this would simulate if you ate a food that had fiber. When the fiber becomes mixed with the juices in your digestive system, we're diluting that food pretty much. And so this is just simulating that effect. And then after I add the water here, I'm going to take the fibers that I brought with me. I have cellulose, inulin, and psyllium. And these are all 3 isolated fibers, meaning that they are in a form that's extracted from the foodstuff, what it was, the plant that it was originally grown in. And so I'll take 2 scoops of each of these fibers. So cellulose here, you can see it's kind of white and fluffy. We'll do 2 scoops of that and mix it up. And can I put you to work here?
Sure.
Do you want to stir that?
Sure, I'll stir.
Oops, unless I make a mess.
And so cellulose is a major component of many plants.
Indeed.
Most plants, indeed, I think all plants, if I'm not mistaken.
Right, it is a major component of the plant cell wall.
Right.
And so we find it in pretty much any plant food that we eat. So it could be fruits, vegetables, grains, beans. It's all going to have cellulose. Now in the middle beaker, I'm adding inulin. Now, inulin we don't typically consume in its natural state. It is found in in onions. It's also found in wheat in a small amount. But for most of us, if we eat inulin, it is found in processed foods like the Fiber One granola bar, or in foods that have added fiber, like there's a double fiber bread that you can buy at the grocery store, the regular supermarket. So we're just mixing some fiber and water here to demonstrate.
The third one that you just put in is?
Oh, sure. The third one, this is psyllium.
Okay.
And psyllium, again, is like inulin. We don't typically consume it in its natural form. This one is actually one of the most popular fiber supplements sold at the drugstore. So I just want to get all this off the spoon, mix it up a little bit more. And then we can talk more about fiber while we let this incubate.
Sure.
As if it were going to be in our digestive system. So give everyone just a little bit more stir.
Last stir, all right. Right, so that is, we typically think of our food as having, at least I think of food as having lipids, that is fats, proteins, and carbohydrates, right? These are sort of the three main things that are in the food, right?
Indeed.
And fiber clearly, to my knowledge, is not a lipid and is not a protein, therefore it must be carbohydrate, right?
Indeed, yeah.
But, but I know carbohydrates are a big group, right? Covers
Right.
sugars and starches, all sorts. So where does fiber fit in this whole thing? I mean,
So the definition of fiber
Right.
is that it's a carbohydrate derived from plants
Okay.
that is non-digestible, meaning our own natural enzymes that we find in our mouth, our stomach, and our small intestine, they can't break that fiber down. That means we can't absorb it into our cells.
Okay,
So the fiber that we have in any of these beakers is a non-digestible carbohydrate, and compared to something like starch that we find in potatoes or rice, that's a digestible carbohydrate, meaning our enzymes can break it down into smaller units and we can absorb that into our cells.
right. Indeed, you can notice that with the starch, right? When you take something starchy and chew on it for a while, its taste changes
It
and becomes
can,
sweet.
yeah, right,
because
and
you're
that's
breaking-
digestion.
You're breaking the starch down into the simpler sugars, right?
Indeed,
Right,
indeed.
okay.
So you could chew on fiber all day long, it's never, ever gonna start tasting sweet. But the neat thing about fiber is some types of fiber, when they reach our large intestine, also known as the colon, those can be broken down by the bacteria that reside there. So if you ever feel side effects like gas or bloating after you've consumed maybe a bean burrito or something that has a ingredient that's rich in fiber, that will be the gas the bacteria are producing because they're breaking down that fiber into other compounds.
Okay, okay. But that doesn't happen with all of the fiber, right? I mean, this is...
No, not
right,
all of them.
right,
Not
right.
all of them. So some types of fiber are what we call non-fermentable.
Okay.
That means when we eat them, they pass through our entire digestive tract untouched. And you might be able to see that in the toilet a day or two later. And there's properties in or fiber in foods that is both fermentable and non-fermentable.
Okay.
And we'll talk a bit about viscosity as we look at our demonstration
Oh.
outcome in a little while.
Okay, so I've heard the term soluble and insoluble too, right?
Right, right.
And so that is this a similar breakdown?
Well,
Or
you know,
is it a different?
This is a little tricky. So the solubility, we often will, hear about that in terms of the health effect. Soluble fiber prevents heart disease. Well, solubility really refers to a fiber's ability to dissolve in water.
Okay,
And there are analytical ways we can measure that in the research lab. It doesn't necessarily translate to a specific physiological effect, though. So that's the tricky thing.
Okay.
So we'll be able to see a little bit about that in this
Okay.
demonstration. Insoluble fiber generally is non-fermentable,
Okay.
but there are some exceptions.
Okay.
Soluble fiber generally is fermentable, but there are some exceptions. And this is why nutrition can be kind of confusing and frustrating for the average person.
right, right. Huh. Interesting, okay. So, but what is sort of the general role then of fiber in our diets?
Well, fiber is going to play a couple of different roles.
Okay.
Some types of fiber, let's say, we'll start with the non-fermentable fibers.
Okay.
Those are going to add bulk and create kind of like a roughage in our digestive system. This will allow us to pass stools more easily, so they can have a laxative effect, ease constipation if you're suffering from that. So that's one good property of fiber. Another property of fiber is that it can delay absorption of certain nutrients. So for example, you've probably heard that oat fiber can lower cholesterol.
Right.
And that's because oat fiber is very thick and viscous. When it's in the digestive tract, cholesterol that might also be a part of that meal is poorly absorbed, and so then the cholesterol can't get into our bloodstream.
Oh, okay.
And then the fermentable fibers, which are broken down by our gut bacteria, those can produce beneficial metabolites that improve colon or large intestine health.
Oh, okay, okay.
So those are the three main properties.
Okay, so it's important stuff.
Yeah, yeah, indeed.
You got to have it with you. That's great. And fiber is basically in all plant foods, right? I mean,
Right, pretty much everything is going to have a little bit of fiber because plants are made up of cells.
Right.
And the cell wall will be made up of cellulose and maybe some hemicelluloses, but the amount of fiber will differ depending on the food source, depending on the plant.
right.
Can I give you an example
Sure,
here?
yeah.
So let's think about whole grains. We all hear, whole grains are really good for you.
Right.
Whole wheat has 3 to 4 times more fiber than whole grain rice. And guess what? Whole grain rice is brown rice. So when we think about just one class of food like grains, the fiber content of whole grains, which have the most fiber of any of the grains, really varies depending on the type of food you're eating, whether it's whole wheat bread or brown rice.
Okay, well that makes some sense. So where am I going with this? The idea is then that if you process this though and stop doing the whole wheat, you're losing a bunch of the fiber, right?
Indeed. Right. So if you eat white bread,
right,
that has the wheat endosperm, the starchy part, right, and the bran and the germ layer, which contain fiber and also some other nutrients, right, like vitamins and minerals, those have been removed.
Right.
So when you eat whole grain foods like whole wheat, whole rye, whole oats, you're getting the full package, which includes fiber and also vitamins, minerals, and compounds that we call phytochemicals that are some of the cutting edge compounds in nutrition.
Sure. And this is, of course, you're then eating much more sort of a natural diet, as it were, the diet that our ancestors would have eaten, would have had.
Indeed.
All these unprocessed foods with lots and lots of this fiber in them.
Indeed.
So do we, in general, now you think in a typical modern Western diet, are we shortchanging ourselves on fiber? Is that sort of an issue?
Well, in a typical American diet, we are. So the average American adult, both men and women, are eating only about half of the recommended intake of dietary fiber on a daily basis.
Wow.
Yeah. And our recommendations for fiber intake are based on the amount of fiber needed to prevent heart disease. And that's a major health concern in our aging population. So you can see, we have some dietary choices we could make, and, the choice is yours.
All right, excellent. We're gonna explore this more deeply when we come back. Right now, we're gonna jump to a quick little break. You're here with me on Likeable Science. I'm your host, Ethan Allen. With me today is Maria Stewart. We're talking about dietary fiber. We'll be right back.
Here's the deal. I'm Jay Fidel. I'm the host of Hawaii, the State of Clean Energy, which is the Energy Policy Forum's program on Wednesday. That's how we call Wednesday Energy Wednesday. We call it Energy Wednesday every Wednesday. Are you surprised? Okay, and we get guys like Jim Alberts here from Hawaiian Electric who can tell us what's really going on in energy. We want to be informed. It's so important. It's the most important initiative in our state. Clean energy is major, okay? And that's why we cover it on this show. That's the deal. What do you think, Sharon?
I think that's great. That's why we're here every Wednesday from 4 to 5, and we hope you all join us so we can hear people like Jim coming on our show and co-host Ray Starling from Hawaii Energy.
Okay, Jim, you've been here today. You've seen this. You heard what she said. What do you think?
I think it's a tremendous opportunity for people to come together and talk about the issues. Oftentimes, there isn't a good forum to bring these key issues out into the public, and this is a tremendous way to go about it. And the activity of this show is essential to keep talking about energy because, as you said, it's such an essential part of our lives that we need to pay attention to it and we need to think about the future.
Okay, Ray, your turn.
Well, this is a special time in the history of Hawaii where we're making some pretty radical changes in the way we use energy and generate energy. And this show is the one place you can count on coming to every Wednesday and hearing something about the latest issues that are on the table, being discussed, that will affect us all going forward. So come join us, and if you have some ideas you want to share with us about energy, give us a call and let us know. We'll put you up here and let you talk for an hour. So come see us.
Thanks, Ray. Thanks, Sharon. Thanks, Jim. It's great to be, from Think Tech's point of view, it's great to have this show. We love the show. It's our most important show. So come around and listen to us 4 to 5 on Wednesday. Thanks a lot. Bye.
Aloha.
Aloha.
And you're back here on Likeable Science here on Think Tech Hawaii. I'm your host, Ethan Allen, here on Friday afternoon. With me today on Think Tech Studios is Dr. Maria Stewart from the Department of Human Nutrition in Food and Animal Science at UH Manoa. And we're talking about dietary fiber, the ins, outs, whys, and wherefores, and all the good stuff about it. And we had started at the beginning of the show, and she'd started doing a little setup here. And we have these 3 beakers in front of us here now with 3 different kinds of fiber. And if we can pan in on them, we can talk a little bit more about the distinction amongst them. So you have the cellulose, the inulin, and the psilocin?
Psyllium.
Psyllium,
Yep.
sorry, I can't even
Yep.
read it. And these are all three fiber types that are in plants. We tend to eat a lot of cellulose and less of the other two you were saying.
Correct.
But we still get some of the other two. They're parts of a normal diet,
Right.
presumably.
Right.
Even though all of our American diets are too short. Yeah. Here they are now on screen. Now, so you
Sure, yeah, let's look at what happens. So
Right.
remember, we were simulating what would happen to fiber after we chew it, swallow it, and it starts mixing with the liquids in our digestive system. So let's take a look first at the cellulose. You'll notice at the bottom of the beaker, it's very dense looking. And towards the upper part of the beaker, it's much more translucent or transparent. This is the cellulose sinking to the bottom of the beaker because cellulose is an insoluble fiber.
Right.
It does not dissolve in water, and you can see it right here. You know, Ethan, you did a great job mixing it up a few minutes ago. It's all now
Right.
sunk to the bottom
Right.
because it doesn't dissolve with water.
Right.
So this is kind of what the fiber would do in your body. It's going to just take up space.
Right.
It will, add more bulk, so
Right.
your food can pass through your digestive system a little bit more efficiently.
right.
Now, if you move on to the inulin in the center, you'll look through that beaker and you can see that it's, very clear, colorless. That inulin has dissolved completely. And this is a soluble fiber. And if you notice when I stir it, it's very easy to stir. It's all, just pretty much water
Right.
with this fiber dissolved. There's no viscosity. There's no big chunks.
Right. The fiber is basically dissolved and sitting in small pieces between the water molecules fundamentally.
Right, and so, you can think of this
Right.
as like Gatorade, which is sugar dissolved in water.
Right.
This is fiber dissolved in water, and actually if you were to taste this, it would taste sweet.
Okay.
So this is a soluble fiber. It is non-viscous because
Okay.
it didn't form any kind of gel. It was, still very easy to stir.
Okay.
And then our third fiber here is psyllium. And psyllium,
very
we'll
different.
see what happens here.
Ah, yes.
So when I work with students in grade school, they'll say, "Oh, it looks like applesauce," and it's not the fiber that we would find in apples, but you can see it's very thick and viscous.
Right.
And I added 2 scoops of fiber to this, just like the other beakers. But this one is a viscous fiber that will form a gel when it's in your digestive system. And this will delay absorption of carbohydrates, such as glucose. So this can be used for a diabetic patient to help blunt that glucose spike after a high carbohydrate meal. Also for the individuals who are trying to lower their cholesterol, if they have this as part of their diet, it's going to make a more viscous gut content, so cholesterol is going to be more poorly absorbed, same with lipids as well.
But equally, it'll block the absorption of almost anything else, right?
Indeed, it'll
So
slow the absorption of minerals,
vitamins,
vitamins.
Right.
Yeah.
So it's sort of a two-edged sword, as it were.
Indeed,
A
indeed.
blunt,
Yes.
sticky two-edged sword. But
Yeah.
excellent. Okay, so then, in some sense, this term fiber really it's covering a lot of bases here. We can see.
Right, right. And on a food label, the Nutrition
Right.
Facts Panel, which is our standard label on processed and packaged foods in the United States,
Right.
has one line that says dietary fiber. And
But it tells you almost nothing then.
right, and occasionally you'll see a second line below the line dietary fiber, and it might say soluble fiber. And so
okay.
that would be the subset that can dissolve well in water, so it might be referring to inulin, could be referring to psyllium.
Okay.
But it doesn't
But-
designate what
Right.
is actually in that food.
Right. They're obviously going to have very different impacts on sort of the nutritional value of the food and how much what it's doing.
Absolutely.
Yeah.
So when we hear, people who have high cholesterol should eat fiber, they should only eat certain types of fiber, really. It's the viscous fibers.
Okay.
Or people who want to have more easier bowel movements to aid in constipation relief, they should have different types of fiber in the diet. So to think that fiber is all the same is really a little unfair to fiber.
Right, right. No, it's one of those terms sort of like cancer, right? It covers a lot of different bases,
Exactly.
a lot of different causes, a lot of different effects.
Right.
And it's sort of the same kind of
Exactly.
thing here. So
Yeah.
it's well, that sounds like it could be a real quest then to get people to understand more and better. There are at least 3 different main categories here. I
Right.
suspect there's far more.
Oh,
You know,
indeed,
Lots of other
indeed.
ways to slice and dice fiber,
Yeah.
as it were.
Yeah, and I have folks ask me, oh, so if I want to lower cholesterol, I should have brown rice. I'm, oh, no, because that's the other kind of fiber, that's the insoluble fiber. So it's not going to help lower your cholesterol, but it will help, move your digestive system along. So
Right.
there are benefits to all of these.
Yeah. Okay. Okay. Well, that's amazing. Then this is a rich area that I knew nothing about. It's out of my realm for sure. So getting back though to the issue that we're all getting only about half the amount of fiber that we should, according to some baseline level. Meanwhile, we're getting like far more sugar and salt in our diets than we probably need, as well as higher levels of protein than we probably should have. So this then is certainly part of sort of the non-communicable diseases that beset Western societies, part of the issues of obesity, diabetes, all that, it relates to some extent to the...
Absolutely. So one of the benefits of fiber, especially the viscous fibers and the insoluble fibers, is that they can help us feel full longer after a meal. So if you were to have a fiber-rich breakfast, All Bran as an example of a fiber-rich breakfast cereal, that will make you feel full for maybe 2 or 3 hours after breakfast versus a low-fiber cereal, maybe like Rice Krispies, that can be metabolized and digested right away, and then you'll feel hungry shortly thereafter.
This is why I notice when I eat my oatmeal every morning, and it leaves me
Right,
feeling...
and if you let your oatmeal sit on the table too long, it'll turn out like that psyllium. It'll become, very viscous and solid even.
Yeah, exactly. And you want a little of that with your oatmeal when you cook it, but not
Right,
too
but
much.
not too much. Right, yeah.
Excellent. So where would oat fiber fall in this then? It is more like the psyllium, you're saying?
Yeah, oat fiber would be like the psyllium. So like if you do make oatmeal and you let it sit too long after you've microwaved it or cooked it on the stove, it will start to get thicker and thicker and thicker. And if you put it in the fridge, eventually you'll be able to remove it from your container in one solid mass. That's all the fiber gelling and solidifying. And it doesn't solidify in your gut, but it does make that viscous gut contents, and will delay absorption of certain nutrients.
Wow, that's... Okay, well, so then people should have more fiber, but it depends sort of upon who you are and what your specific needs are as to what kind of fiber you want.
Yeah, and for a person who's healthy and just wants to increase their fiber intake, eating fiber from a variety of sources will help, reach that fiber total intake requirement, but also providing some of these different properties to the body. So, eating several different types of fruits and vegetables and switching out some of the refined grains to whole grains, adding beans into the diet because that has a fermentable fiber. Those are all great ways to achieve more of a fiber balance in your diet. Yeah.
Which is what we actually all do want, right? You're sort of saying we want at least probably a little bit of each.
Right,
And yeah, so that's intriguing. I sort of didn't realize you were supposed to balance your intake of different things. But it makes sense, again, to talk about eating a varied diet with a wide palette, as it were, fruits and vegetables, and that's going to give you that kind of thing versus eating just primarily one issue. And so again, this is why this has to do then with the poor diets that we see in some places in the more remote Pacific Islands, where people tend to eat a lot of white rice, not a lot of other of their traditional staple foods, not a lot of the fruits and vegetables that they used to actually rely on. But go more for some of the processed foods, and they're now suffering some of the top 10 nations in the world, or Pacific Island nations, for obesity and diabetes rates. So interesting. So where else do you there's more to nutrition than just fiber, right? I mean, is this really your sort of specialty, or do you?
Yeah, so I'd say this is my specialty. My research lab at UH Manoa has focused on properties of dietary fiber that's found in tropical fruits. So since I've come to Hawaii since 2009, I've shifted my research focus to include some of the locally relevant foods, and that actually includes rice as well as tropical fruits and avocados.
I was wondering, so I've fallen in love with papaya since I've gotten here. How do they rate on fiber?
They have a moderate amount of fiber. So, fruits and vegetables, in terms of like a density of fiber, they're not very dense. They don't have as much fiber per gram as like whole grains because they have a lot of water, but obviously they contain a lot of good nutritional value through vitamins and minerals. So recently we did a study on the breakdown of fruit fiber by the gut bacteria. So in our large intestine, we have over 1,000 species of bacteria living there, hopefully in harmony with us. We'll know when we're not in harmony
Right.
with our bacteria.
Right.
And those bacteria can break down many different types of fiber, including some fiber from fruits. So we measured how quickly the bacteria broke down those fibers and what kind of end products were produced. And the papaya fiber was kind of an intermediate type of fiber in terms of breakdown rate. Mango fiber was broken down very rapidly. And that's, when we measure that in a research lab, that's an indicator of maybe perceived gas the person would feel if they ate the food as a whole food. So they might feel that, oh, this is kind of disrupting my GI tract. So papaya had a fermentable fiber, but it was moderately fermentable, so it's not likely to cause any negative GI side effects for the consumer.
Interesting. And then you said you were looking at avocado also?
Sure. Some of my work with avocado has focused on fatty acid content.
Okay.
And to me, if you've had local avocados in Hawaii, you know that some of them are very rich and creamy, some of them are more watery and stringy. And so the fat content of avocados is quite variable depending on the cultivar or variety. And we found that the avocados grown in Hawaii have a very high fat content. So it's considered like a grade A avocado, premium grade avocado. And it does these avocados do contain some of our essential fatty acids.
Okay.
So you maybe have heard of omega-3
Right.
and omega-6 fatty acids. There is a small amount of those essential fatty acids in locally grown avocados.
Oh, excellent, excellent. Well, that's great. So there's quite a lot of different avenues then to be explored here in your work, right?
Absolutely. Our national nutrient databases cover mainland diets very well. And as I learned once I moved to Hawaii, the local diet is a little bit different.
Right.
And so some of the nutrition resources we have for local foods are a bit limited. Some of the analyses were conducted decades ago, and so we need to update, our nutrient analysis information. And there's a couple resources available through UH Manoa, such as the Hawaii Foods Project, that provides just even the everyday consumer with information about local foods and the nutrient content.
That's great, because there's more and more of a trend these days to eat locally and source more of
Right.
your foods locally, and it particularly makes sense in a place like Hawaii, where we ship in so much of our food. We should be trying to find more local resources and all. Excellent. So we're gonna take another break here at this point. I'm your host, Ethan Allen. You're here with us on Likeable Science. Dr. Maria Stewart from UH Manoa, the Department of Human Nutrition, is with me today. We've been talking about dietary fiber, and we'll be right back.
Aloha, my name is Josh Green. I'm a senator from the Big Island. I work in the ER there. But on Tuesday afternoons, I get to come and spend 45 minutes to an hour with Jay Fidel and the Think Tech staff. They're terrific professionals. They help us to bring some of the leading cutting-edge topics here across our state to you. So you can join us at our show on healthcare in Hawaii to talk with leaders from across all the spectrum of health in our state, or you can join us for any other show where we talk about economic development or tourism or some really eclectic programs too. So really, we'd love to see you here on our show. Thanks for joining us and thanks for supporting us.
And you're back here on Likeable Science here on Friday afternoon on Think Tech Hawaii. I'm your host, Ethan Allen. With me today in the Think Tech studios is Dr. Maria Stewart from UH Manoa, Department of Human Nutrition. We've been talking about her work and particularly about dietary fiber, and the sort of amazingly rich variety of fiber and the different properties of different kinds of fibers. She did a great demonstration for us here of insoluble, soluble, and gel-like fibers, I guess you'd call them.
Soluble and viscous, yep.
Okay, soluble and viscous, right, all right, fibers, and we've talked about how they differ among one another. But you work in a research lab, right? And that's a very foreign world to a lot of people, I suspect, a lot of our viewers. And I think we have some photos lined up that show maybe a little bit of the kinds of stuff that you do every day here. So.
Sure. So these are some photos of a recent project my students and I conducted. This is called an in vitro fermentation. So we are modeling the breakdown of dietary fiber in the large intestine, but obviously monitoring the large intestine is very invasive. So we use these glass bottles to simulate what's happening in the large intestine. And we blend the fiber with a milieu of bacteria. These are from healthy donors who provide us with a fecal specimen, and that provides us the kind of representative bacteria to then model the breakdown of the fiber.
Okay, and
so one of the things we need to do in our bottles that are stimulating the large intestine is create an anaerobic environment.
Okay.
And that's an environment which has no oxygen. So we will flush the bottles with carbon dioxide and also add an enzyme that removes oxygen from the solution within the bottle. And that's really important because we want to make this environment as close to our intestinal environment as possible.
Oh, and our intestine is actually anaerobic.
It is.
I had not realized that.
It is, yes.
I would have thought there would be air in it, but, okay, and moving along then?
Oh, so then this is where we're starting to finally assemble our bottles. We're going to put a rubber seal and then an aluminum crimp cap on top to seal everything in.
Okay.
This is one of the limitations of this type of project. Our large intestine is not a closed system. Obviously, things are absorbing and moving through the organ. But for lab purposes, if we have a closed system, then it's an environment that's very predictable.
Right.
And so we seal our anaerobically flushed bottles with the rubber stopper and the crimp seal to then keep all the oxygen out and allow the bacteria to become as active as they possibly can.
And keep whatever they're producing in, too.
Right, yes.
Right, okay, excellent. And then?
So then our body temperature is 37 degrees Celsius or 98.6 degrees Fahrenheit. That's obviously warmer than our research lab. So we put these bottles in a water bath, and that bath temperature is right at body temp. And so they'll incubate for up to 24 hours. And that's the typical transit time in the large intestine for an average adult.
Okay, okay. And that's,
Then once our incubation is over, one of the first things we want to measure is how much gas was produced. You know, for a consumer, gas production is an aspect that's very noticeable.
Right.
And if we see fibers producing a high amount of gas, that may be an indicator that this is a food that a person would want to consume in smaller quantities. Or if it's a fiber supplement, you know, this might be a supplement to not adopt if you're a manufacturer.
Right.
So we're measuring the gas production
Okay.
during the incubation in this image here. So that's a syringe that my student is holding to measure how much gas has been produced in that sealed bottle.
oh, okay, I see, yeah. So you punch that through the stopper.
Yep.
Okay.
Then our next step is to measure the pH, or the amount of hydrogen ion, the acidic nature of our environment. And typically we see the pH drop a little bit, and that's a sign that we have good products being produced, primarily compounds called short-chain fatty acids.
Okay.
Then we want to stop the fermentation altogether. We want to kill the bacteria, essentially. And so we'll add a solution to cease the fermentation, and then we'll continue processing our samples.
So you see what they broke down
Yep.
into.
And then we'll analyze them and be able to come up with some conclusions about our fruit fiber.
Okay. And so, and when you do this set of experiments, you'll do this with, say, avocados and mangoes and papayas or whatever.
Sure, yep, we can use whole foods, or we could use isolated fiber from supplements. It's a very versatile protocol.
Okay.
And so we're, in this particular study that you just saw pictures of, we were looking at different bananas and to analyze how much of the residual starch that might be present in the banana could be broken down by the bacteria.
Right, and yeah, that's actually gets right back to the whole island food. I had not realized until I came out here how many varieties of bananas there really are. And I
Yeah.
always thought bananas were bananas, but all we get on the mainland typically is one version of bananas.
Right, right.
One cultivar, I guess, which I guess is being threatened by some virus these days
And
too.
yeah, and that's a big concern. You know,
Right.
our monocultures in typical large-scale agriculture could be wiped out by disease. So looking at more diverse fruits and vegetables within the same genre, like bananas, is, you know, one of my interests. So when or if, hopefully it's if, you know, a disease wipes out an entire crop, we have alternatives, and we know a little bit about them nutritionally.
Yeah, no, that's excellent. That's super. So well, I'm going to ask, we take a little jump here and think a little more broadly. So in your work here is a really nice example of how science can play a role in all of our lives. But I want to talk to our viewers for just a moment and have them think about how to sort of behave like a scientist, how to think scientifically, and where this might play a role in their lives. So a good example came to me the other day. Someone shot me on Facebook one of these blurbs, supposedly from Johns Hopkins, from John Hopkins in this case it was, talking about cancer and spewing forth just a bunch of misinformation. They had passed this along quite sort of seriously, thinking this was a reasonable thing to do. And it got me thinking about what does it mean to think scientifically? And you realize, of course, skepticism is one of the sort of hallmarks of scientific practice. Is you don't believe everything you read or you see, and And so you need to check it out, see the evidence behind it, et cetera. And there's so much stuff now on the internet that particularly in health and nutrition, I'm sure, much of it perfectly good, but much of it just, really worthless, basically, or dead wrong, in some cases quite harmful. And so for medical information, right, where do you go?
Yeah, this is tricky because especially in the realm of, food for medical treatment or, a specific health effect, there's a lot of information that's suspect.
Yes.
So, a general rule is a resource that's coming from a .com website, you want to scrutinize.
Right.
Doesn't mean it's junk, but you want to be careful and look at, if there's any credentials behind the authors.
Because they may have a vested interest in a .com, it's a commercial enterprise.
Right.
Somebody may be trying to make money off of this rather than really help people.
Yeah, and
right?
you see this a lot in the supplement industry, which is really unfortunate. So if you're, looking at a claim that a company or a person is making about food and health, you can look to some pretty solid resources such as the National Library of Medicine, Medline, Mayo Clinic is a well-respected resource for healthcare. So you can do some homework by fact-checking. And we see this a lot with politicians.
Right.
Checking facts. You can do it yourself as a consumer by looking for other reputable sources that substantiate the claim.
Right. Right, and there are actually even sort of meta sources now on the internet that do this. Snopes is a source that tries to vet a lot of the information and let people know when there are weird scams and false claims being circulated widely, which seems to happen more and more these days, and it seems easier to spread that stuff now.
Yeah, and especially with diet and health, I mean, if it seems too good to be true, unfortunately it probably is too good to be true.
So, our producer was just asking me, can we trust the nutrition labels we see on boxes and food containers?
Ooh, that's tricky. So, no. It's an interesting situation. So, in order to have a food label developed like this, food does need to be analyzed in a research laboratory. Typically, these are certified industrial labs. Right. But this is an overview or an average of that food. And obviously, growing conditions might change the nutrient content of the ingredients, like the wheat. There might be differences in lot or the production run of the food. So what we see on food labels is an average.
Okay.
And so it may not be exactly representative of what is in that food. We might see slight variations, and up to 20% variation is actually pretty okay, which is
really
amazing.
That's a lot. Yeah.
It is a lot.
Yeah, if you're talking 20% more calories,
right.
less calories, you're yeah.
And the other tricky thing about the food label is these values are based on a serving that's preset by the government, and that's not necessarily what you're going to eat in terms of your volume.
Right.
So with a cereal like All Bran, which is the label that's on the screen right now, if you were going to eat that cereal and you had half a cup, that might fill you up and you might be fine with that. But let's say a snack food like potato chips.
Right.
You're not going to necessarily eat the 8 potato chips or whatever the serving size is. You might eat 28.
Right.
So that's the other concern with the food labels. People are often assuming that they're eating that serving size when they're eating maybe double or triple the amount.
Yeah. Sometimes I wonder when you get these foods and they say, this makes 4 servings, and I look at it and say, I could eat that, sitting here myself.
If you go to the 7-Eleven, you buy the 1 liter Gatorade bottle, it says 4 servings, but most of us will drink that Gatorade as we're driving home.
Okay.
So, one thing I wanted to bring up about fiber, and we have the Cheerios label here. Cheerios is known for its heart healthy effect, and that's based on the fiber that's in the food. On the food label, the nutrition facts panel, Cheerios has actually decided to add how much soluble fiber is in their food, and that's an optional addition on the food label. So if you see at the bottom of the screen, it says dietary fiber 3 grams, soluble fiber 1 gram. That soluble fiber entry is an optional entry, and Cheerios has chosen to do that, to promote their product.
Because that's a fairly high level of soluble fiber, presumably.
It's moderate, it's moderate. But if you read the fine print on the health claim, you do have to eat 4 bowls of cereal in order to reach the threshold for having a cholesterol-lowering effect for your fiber intake.
Okay. But even though it's soluble, again, you have your 2 soluble fibers here that are behaving rather differently.
Exactly, and that's one of the things that's confusing for a consumer. A soluble fiber might be like the Inulin we have on the table, which is clear, colorless, and non-viscous. And it might also be like the Psyllium, which is very, very viscous and will definitely slow things down.
Right, yeah, and they'll have very different then impacts on absorption of other nutrients, absorption of things good and bad, basically.
Yeah, and if I can say one more thing about
Sure.
inulin, this is a fiber that looks pretty inert, nothing special about it, but if you were to eat a large dose of inulin, your bacteria will be thrilled. It'll be like a buffet, all you can eat buffet for them, and they will produce typically large amounts of gas, and there will be pretty serious GI side effects for the consumer. So even though it is clear, colorless, and non-viscous, it is highly fermentable, and that's inulin's little secret.
I see. And there are probably reasons, there are ways to make use of that probably in at least some processes, right?
Oh,
Even if you
absolutely.
don't-
And for inulin, as an example, this is often added to processed foods because it's very easily to incorporate into the industrial food processing system, and it's very palatable.
Okay.
Yeah.
So presuming in small amounts.
In small amounts, yes.
Excellent,
Yes.
excellent. Well, that's incredible, incredibly rich food for thought, as it were, here.
Indeed.
So, if you want to tell, if you can leave your students, as it were, or students at large, with a message about food science and all, what would you sort of tell the students to learn about food?
Oh, right. Well, we eat every day.
Right.
And most of us don't think about what we're eating.
Right.
It's, what's available, what's convenient, what's,
What we've eaten-
affordable.
What we've eaten in the past.
Right.
Yeah.
And so, I encourage everyone to try some new foods and think about foods for health and, the ways that you can, improve your longevity and reduce chronic disease risk may be tied to what you're eating. And if you take pause and consider that and do a little of your own research, you may be able to find yourself living healthier into your, 7th or 8th decade of life.
That's a good point. I know just personally my sort of eating habits have changed since I've come to Hawaii, and I no longer eat big dinners. I used to, before this, I always had a fairly substantial dinner. I had moved in Seattle to eating salads more, but here we often have now just very light little things, a few little bruschetta and sort of little poo-poo kind of finger food, and call that good for dinner, and no longer sit down and have a meat and potatoes and vegetable kind of dinner. And I'm finding it suits me. So it's
Right.
yeah, I think it's great advice for students because it's easier to change dietary habits early in life than later in
Yeah,
life.
and it's what your decisions that you make as a younger person, that's what influences your chronic disease risk as an older person.
Exactly,
Yeah.
exactly. So important stuff. Well, this has been very exciting. This has been very informative and been very enjoyable too. So it's a win-win-win here, And I thank you very much, Maria, for being here on my show, Unlikable Science, and for sharing all your great knowledge and your great demonstrations here with our viewers. And aloha.
All right, thanks for having me on the show.
Indeed, and we'll hope to see you next week on Unlikable Science.